Okay, for question 8, a parcel of mass 3 kg, slide 3.5 meter down a rough slope inclined at 20 degree to the horizontal. The coefficient of friction between the parcel and the slope is 0.5. When it reaches to the bottom of the slope, the parcel has a speed 8 meter per second. Use the work energy principle to find the speed of the parcel at the top of the slope. So for this question, same things. This question, you have an item here, 20 degree, and you have a R here, and you have a F. And don't forget, and you have a vertical force, 3 kg is 30 Newton. Okay, so for this question, same things, you will apply the principle in before and after. Okay, let's see before and after what kind of energy that you have. So if I draw a diagram, it is not necessarily like if you want to draw it not just if you want to direct put into the equation also can, no issue. Okay, before the KE that you have 1/2 mu square. The PE that you have mgh, so is equal to mgh is 310 and multiply 3.5 sine 20. Okay, and Ke after you have 1/2 mv square, so 1/2 m 8 square. Okay, and reach to the bottom of the slope, Pe equal to 0. Don't forget, you still have work done by friction between the parcel and the slope. So right in the next page. So the work done by friction is equal to 3.5 times 3.5 is the distance times the mu r, and 0.5 times 30 cos 20. Right. So this work done you may simplify as 52.5 20 cos 20. So that you can use the exact value for calculation. So once you have this before and after energy, now you can put inside the energy equation 1/2 mu square plus the PE. P is 33.5 sine 20 minus the work done for the fraction is equal to after 1/2 mv square. So once you have this, and you can do the further calculation. So 1/2 mu square will be equal to 96 plus 52.5 cos 20 minus 30 times 0.5 sine 20. So from this, your U should be equal to 8.54 meter per second. Okay, so this is for question 8, before and after. And now we move to question 9. For question 9, a car mass of 1500 kg is traveling at 64 km per hour along a level road when the driver sees a ball roll out onto the road and in front of the car, the driver takes 2 seconds to reach to then applies the brake. Using the maximum braking force, the car comes to rest at the end and just missed the ball. After traveling total distance of 80 meters from the driver first saw the ball, assuming that the wheels lock as soon as the brakes are applied so the car slide and the air resistance can be ignored, find the coefficient between the friction between the tires and the road. So, firstly, you may change this 64 km per hour to meter per second, so 64,000 over 36,000, 60 times 60. So you should get 177,019. Okay. So, and the driver take 2 seconds to react. So we need to find the distance that he traveled in these 2 seconds. So 2 times 17. Okay. So for 2 seconds, distance that travel. So this, if you multiply, this one will be equal to 35,519. Okay. And the total distance that travel after first saw the ball, so you can see that the distance that for braking period will be for braking, distance for braking, D for braking will be equal to AD minus 35,519. So you should get 44,419 for this instance. Okay, so this 44,419 will be for the braking distance. So once you have this, you know that the KE at the beginning is 1/2 M 709/2, and after the brake KE equal to 0, stop already. So, and you have a work done to overcome the friction 1/2 work done overcome the friction. Okay, so you don't have other things that you don't have the coefficient of friction, so we just put as a work done. Okay, so then you can group 1/2 M 1/2 M is square, mu square is equal to minus the work done is equal to 0. Stop already. Okay, so that let's simplify this. You know that work done is equal to 1/2 M. So the full kinetic energy will be used to overcome the friction because you want to brake and stop. So, and you know that this is the equal to the friction that multiply the distance, right, is equal to this. so that you know that the force that you apply is equal to 1/2 1500 1770/9 square over the distance that you travel just now for braking, so it's 44,419. Okay, and now if you want to calculate the coefficient of friction, and you know that F equal to mu R, mu will be equal to F over the R is 15000. So by doing this way, you put the exact value just now inside here, you should get mu equal to 0.356. So the coefficient of friction is equal to 0.356. So for this question, if you should keep the friction from the beginning until the end. If you use the round-off value, your answer may be a little bit different when it comes to 3 significant figure. So try to keep the friction for calculation purpose. Okay, so this is for question 8 and question 9. Okay, now we move to the last part of this energy. Okay, we have a last part, power. So power we define as P equal to Fv. F is the force at the instant, V is the velocity at that instant also. And the unit for this, for power, will be, you can write as joule per second, or most of the book will use for watt, right? Okay, so this is the definition of power, will be rate of doing works. Okay, so how many energy that come out in the particular second. So you have a very general formula for power at the particular instant, and at the particular instant you may have another formula. If you change this, the force at the moment will be equal to P over V. Okay, so if you want to put this F in a net force equation, P over V, because this is the force that work done on the particular, so will be positive. So minus all the opposite, all the expenses forces is equal to MA. All the opposite forces can be friction, can be resistance, or can be any forces that opposite to the direction of movement, so is equal to MA. Okay, so if I simplify, P over V minus F, I put opposite direction of movement, is equal to MA. Okay, so and you know that at the maximum velocity, no more maximum already velocity mean no more changing of the velocity, so A will be equal to 0 because no more changing of the velocity at the maximum, at max V. A will be equal to 0, no more changing. So simply you reform the equation, P over V will be equal to the F. So all the power that you generate will be used for overcome, okay, the forces that opposite to the direction of movement. So this is the formula that you will use in order to calculate the problems in the power. Okay. So now we move to question 10. Okay, for question 10, a car of mass 1500 kg is being driven along a level route is accelerate from 0 to 100 10 seconds. Air resistance and friction may be ignored. Find the average power generated by the engine. So same things, you can apply the before and after principle. So I changed the kilometer 100 kilometer per hour to 1,000 to 3600. So you should get 27,709. So you still can use the before and after principle. So I direct put the before and after energy in the principle. So 1/2 mu plus work done don't forget this is work done by the driving force, so positive. Okay, put on the body. So 1/2 mv square. So work done, I put work done simply will be equal to 1/2 mv square mv2 minus mv1. Okay, but you know that mv1 equals 0, so it's equal to m 27,709 square. Okay, so this is the things what done, and so that your average power will be equal to 1/2 m v square over total times that you travel 10 seconds, power over time, so joule per second. So by doing this way, you should able to get 57.9 kilowatt, right? So this is the average power. So what you mean average power? So we assume that the power is consistent along the way lah. But the power is depends on the velocity. Actually, the velocity for the power, okay, average power mean average on the all the we when you have average power means this is the mean for the power. Actually, the power can be changed along the way, because you know that uh, P equal to FV. Okay, so you need to consider if the velocity change, okay, and the force change. If your driving force is a constant, let's say, okay, and your velocity change, actually your power will change along the way, right? So when you're using this way to calculate the power, so you assume that you will get a mean for the power, right? Average power. But the real power actually change depends on the velocity. Okay. So now we move to question 11. Question 11, a car of mass 1,500 kg has an engine that has a maximum power output of 200 kilowatt. The resistance to motion is typically 5,000. Find the maximum speed that the car can achieve on a level of road in all the legal speed restriction. Okay, so for this question, resistance is 5,000. Okay, so we can apply the principle. Find the maximum speed. So we use the general one, P over V minus F is equal to MA. And maximum speed means P over V will be equal to F. So V will be equal to P over F. So you can P will be equal to 200 kilowatt, 1,000. F will be the resistance, 5,000. Okay, by using this, you calculate, you should get the velocity is equal to 40 meter per second. Okay, quite easy, right? Question 11. Okay, now we move to question 12. Question 12. The car of mass 1500 kg has an engine has a maximum power output of 200 kilowatt. The reason to the motion is typically 5000. Find the instance acceleration of the car when the engine is working in the maximum power and the car traveling to 20 meter per second. Okay, so question 12, same thing, P over V minus the resistance is equal to MA. Okay, so now you have the question asks you to find the acceleration, so you cannot put it at 0. So shift everything to the one side. P over V minus F over M. You have 200,000 maximum over the velocity minus 5,000 over 1500. Okay, so by this way you should get your A is equal to 3.33 meter per second square. 3.33 meter per second square. Your A is equal to 3.33 meter per second square, right? So this is for question 12. Okay, for question 13, a car of mass 1500 kg has an engine maximum output of 200 kilowatt. The resistance to the motion is typically 5000. Find the instant acceleration of the car when the engine is working at the maximum power and the car is traveling at 20 meters per second up the hill at the incline of side inverse arc size is inverse size 0.8 to the horizontal, so sine theta will be equal to 0.28. Okay, so for this question you still use the formula P over V minus F equal to MA. So this is the opposite forces, so you can group A equal to P over V minus F over 1500. Okay, so for this question, what kind of opposite force that you had for this question? Now we put the values inside. The power you have is 200,000. And you have a resistance. And don't forget, you have the force that bring the item down by the weight. So 1500 times 0.28. These are the forces that opposite to the direction of movement, opposite force. So over the weight 1500. Okay, so these are the things: the power generated by the engine, air resistance, and the weight, the force that bring the item down by the weight. Okay, so by calculating this, you should get your A at the particular moment. A equal to 0.533 meter per second square. Okay, so this is the last question for the power, and we have cleared the syllabus. Okay, so next class we will move to some revision for paper 4 first, and for paper 6, 7. For paper 6. Okay, once done, we will move to further mathematics. I think for May and end of May, or maybe in June, you have a lot of assessment, and we try to spare some time for the further mathematics. And I have posted a question for you to solve for today. Okay, thank you.